All right, first let me show you the power of the law of cosines, and then let's see if we can derive this real quickly. It's just a really great property. For example, if I call this angle A, this B, this C, okay, opposite A, little a, opposite C, little c, opposite B, little b. Oh, okay, little b, there we go. Now, if this were a right triangle, and it sort of looks like one just a little bit, pretend C is a right triangle, then we could see, wow, super easy, right? A squared plus B squared equals C squared. So if you know any side, you can find the other two. Well, that's the power of the law of cosines. This actually also works for if it's not a right triangle. So let's pretend C is not a right triangle. You should be pretending right now it's not. Let's say that I'm given A and C and this angle right here, B, the included angle between the two sides, A and C. Well, what's really cool is if you know the length of A, the length of C, then B is super easy to find, because B squared is going to equal A squared plus C squared. That's all it is. The only thing you have to do, there's just a little glitch, you have to subtract off 2AC cosine of the included angle B. See? It's kind of cool. So for example, if I know that this side of the triangle is 7, this side of the triangle is 10, and I know this angle right here, let's just say this is a 45-degree angle right here. Bam! All I have to do to find B then, if B is possible, we'll find out right now, we could take a 7 squared, so 49 plus 100, 149, right? And we're going to subtract off 2 times 7 times 10 times the cosine of 45. Cool or cool? Cool? Say this is cool. It's cool, right? So we can see here that B squared is going to equal 50, so raise that to the 0.5, 50 point something. You know, it's not exact, but it's close. And take half of that, so square root of that is about 7. So B would have to be, if that really is a 45-degree angle, B would have to be about 7 units. You know, like miles, inches, whatever. 7 units here, and this is 10 units down over here. If this is really true. Cool? Cool or cool? Are we saying it's cool yet? I hope we are. All right. Now, what happens if, instead of this angle right here, what happens if, let's just redo this real quick. Okay. Opposite A, I have A. Opposite C, I have C. And opposite B, I have B. What happens if I know BC? Let's just say I know B, I know the length C, and I know the included angle right here, A. Okay, we'll call it theta, but it's really angle A, right? You see that? Okay, now this time I want to find A. A equals what? I don't know A. So A is what I'm looking for, and this is, you just always remember, it's kind of Pythagorean. A squared equals B squared plus C squared. You could always do that. Just remember to subtract off this little bit. Subtract off twice BC cosine of the included angle, the angle between the two sides, you know, cosine of A. So once again, let's make it up. Let's say B is, I don't know, 5 units and C is 11 units. Let's just say that. And let's say this angle between them is, let's pick a different one. Let's do like 25 degrees. Let's say this is a 25-degree angle. Okay, so now do you see it? Cool beans, right? Do you see? A squared is going to equal B squared, so it's going to equal 25 plus 121, right? 25 plus 121 minus 2 times 5 times 11 times the cosine of 25. You got to make sure you're in degree mode. Make sure you're in degree mode. All right, so I get A squared equals 46. Well, if that's true, A squared equals 46, raise that to the 0.5, and I get 6.8 or so, so about 7 again. You guys are thinking I'm not doing anything, but I am. Really. So A is approximately 6.8 units. If we were going to round to one significant figure, we could say it's about 7 units again. But that's just, now that should be like over the top cool. Do you get that? Do you see how it works at least? See how it works. Okay. Now, what happens? I mean, and it's the same thing here too. Oops, just erasing. I can't remember what I did there, but let me do it one more time here. So just want to make this really clear. If I have A, B, C, something like that, opposite B, little a, little c. And let's say this time that I'm given, I know length C, length A, and the included angle up over here. So once again, what I'm trying to find is this side over here. So B squared is going to equal A squared plus C squared minus, you have to subtract off the 2AC cosine of B. All right, that's what we want to prove. Let's prove this. All right, so to prove this, what we're going to do here, I'm going to redo this one more time. We've got A, B, C, little c, little a, little b. I'm going to drop an altitude right here. And let's say that this height right here is v. Let's actually say, let's drop an altitude. Let's put our triangle on the coordinate plane. Can we do that? We can, right? The coordinates of A are 0, 0. And the coordinates of B is going to be over U, and up V. That's the coordinates of B. And C, we won't worry. I mean, C is going to be, you know, at 0, B, whatever length B is there. That's going to be C. Okay, A is at 0, 0. C is over at 0, B, and B is at UV. All right, the first thing I want you to see here is that the sine of A, remember sine is opposite over hypotenuse. The sine of A is V over C, right? And the cosine of A is going to be U over C. It's going to be U over C. Okay, now I can't remember what I'm doing. It'd be nice if I, like, sometimes write stuff down. What do we know? Oh, in the little triangle, do we know anything in the little triangle? Oh yeah, no, we know A. Look, we have a right triangle right here. I got it, I remember now. Let me even do this. Let me do this in red or something. See, in this triangle right here, we do know some stuff. This is a right triangle right here, right? And we know V squared plus this length right here. Now remember, all of it is B, and this portion right here is U. This part of it right there is U. So we know B minus U squared is going to equal A squared, right? V squared, this portion right here, right there, that's going to be B minus U equals A squared. But look, we know what V is. V is C sine of A, right? U is C cosine of A. So let's see if we can get this, let's just simplify this with a bunch of algebra now, right? So V, let's see, we're going to get C sine of A squared plus B minus C cosine of A squared equals A squared. And let me see if I can do this. So C squared sine squared of A plus, and now this is going to be, you know, working this kind of foiling at B squared minus 2bc cosine of A. That's going to be my middle term, and then my last C squared cosine squared of A equals A squared. Oh, check it out, there it is. This is so fun. Look at this, because we've got C squared sine squared of A plus C squared cosine squared of A. See that? This one and this one, bring those two together, plus B squared minus 2bc cosine of A equals A squared. And you can just see right there, this is going to be just C squared, factoring a C squared out, C squared times 1. Do you see it? Because look, you factor, I don't know, I'll write it out just in case, but isn't that fun? There it is right there. 2 minus 2bc cosine A equals A squared. Didn't mean to. Let me erase that little bit right there. My messy paper. Any more messy than we already are? Than me already is. So you can see this is just 1, right? So C squared plus B squared minus 2BC cosine of the included angle A equals A squared. And there it is. And it's true, I could have solved for B or C, either side, and by the same reasoning. All the other ones are true too. So that's it. Thank you.